Hi, in this video I will show you how to upgrade AWS EKS cluster with using Terraform. Here we will have an AWS EKS cluster at version 1.3.0 which is managed with using Terraform. Now we see that how we can upgrade that AWS EKS cluster to version 1.3.1. So here the complete end-to-end upgrade process will be handled by Terraform. So in that perspectives, in this video, you would see how we need to manage this task from end to end. And while upgrading this process or while managing this upgrade process, how do we maintain the availability of the application that is hosted on this AKS cluster, right? So here I have already, achieved this upgrade process. Now what I do is, I'm going to walk you through those step by step and show you that, how did I reach to this particular milestone from upgrading an AWS EKS cluster from version 1.3.0 to version 1.3.1, right? And during this upgrade process, I would also show you that my application was running and it was never went down. Okay, so with that, I will take you to the my VS Code first, and in this VS Code, I have kept the source code of Terraform, where at initial state my EKS cluster was running at version 1.3.0. So first, let me tell you like how does this source code is been set up and how was the cluster was at version 1.3.0, then how did it get migrated or basically upgraded to the version 1.3.1, right? So as you see here, I have just now completed the upgrade process. By the way, I'm going to show you the all the Terraform command that I have run, and before I do that, I would like to walk you through this particular source code. So this is the source code. I have kept it in my GitHub repository, and I would share this GitHub repository link in this video's description. You can find it from there and try to try to use the same thing or try to use it for troubleshooting from your side. All right, so here my EKS cluster is being managed, or basically the EKS cluster components are managed as a modules. So for that, I have a folder called modules. In that, we have the the four subfolders, which includes EKS, IAM, security group, and VPC. So as the name says, EKS, this is the folder where it has the definition of, or basically the source code to create the EKS cluster components. So if I can enlarge this one, as you see here, it contains the EKS cluster definition. So I don't want to walk you through the, line by line, but just a quick walkthrough so that it will become easy for you to while you look at the source code from the GitHub repository. So this is the AWS EKS cluster. It has the availability zone, and we are declaring a template, that is launch template, right? And then obviously the AWS EKS node groups, right? We have one node group, and then within the node group, we have the add-on configurations. You see that we have declaring a add-on local variable, right? So within that EKS cluster, we have the add-ons. The add-ons that is I'm placing in this cluster is VPC CNI and the kubeproxy, right? So that is the at a higher level the components of my EKS cluster. In this EKS cluster, we are hosting an example application, and that was running before I start the EKS cluster upgrade. So that is the EKS cluster. Now I go to the IAM roles. So the my EKS cluster has a certain IAM roles. It has a two IAM roles. One is for EKS master, which is assigned to the EKS cluster level, and it has the these many permissions. So basically, I have given full admin privilege because just to make the things easy. But again, in your case, you need to provide the required access. And then again, if you go down, we have another role called the worker role. So this is my worker role, right? And this is basically has the equal permissions as I have given for the master nodes. So that is about the IAM role. So I will not go through the each one. So let's go to the next one. So next one is, this is the the folder which depicts the, or basically which defines the AWS security group that is used in this cluster, right? And likewise, the other files, output file and variable files, are meant for respective task, that is declaring the variable and outputting the outputs of the resource properties. And then we go for the VPC. So this is the VPC which creates a VPC where my EKS cluster will be hosted. So it includes VPC creation, internet gateway creation. It has the public subnets being created. It has a route table to those subnets, and then the route table associations are being configured. So under the hood, this is how my EKS cluster at version 1.3.0 is set up. Along with that, I have a couple of, I have a few more list of files, which includes Terraform file. Let me first walk you through this Terraform file. So this is the file which is actually a main.tf file, which will call those modules. So here we have kept the module, and those modules are being called from this particular main.tf file as a module caller. Okay. And then we go to the next provider. So this is the provider block, as the name says. So this is where I have defined the backend configurations of my this Terraform, the state. Basically, the cluster state is kept in this particular backend, that is AWS S3 bucket plus DynamoDB. All right, so that is all about the provider one. I will come back to these two files. So let's go to the TFR file. So TFR file is the file which actually helps you, or basically this is the file which analyzes the cluster upgrade. So right now, when my cluster was at version 1.3.0, so it was here. You see that this is the my cluster name. We are keeping the instance count equal to 3, and then the instance size equal to T2 micro. Region is US West 2. This is the cluster version. This is the AMI ID of that particular cluster, right? So basically, the EKS cluster nodes will be using this image and getting created. Then we have a VPC CNI, the add-on versions, and this is the kubeproxy. Remember that the last two variable values should be retrieved with a certain, the techniques which I'm going to explain it after some time. And then I go to the next file, that is variables.tf file. So this is where the variables are being declared. So likewise, I said, let me first walk you through these other supporting files. So one is help PowerShell file, and then the result.json file, and then the sample applications. So first, let me take you to the help.PowerShell file. As I was telling you that, to retrieve these values, that is VPC CNI and crew proxy versions, belongs to a particular cluster version. So you need to run. You can get these information of respective versions, VPC CNI and crew proxy versions. You can get it from AWS document, but that is very lengthy process. So to make it easy, I have write this PowerShell script. So in this PowerShell script, we have the the variable called Kubernetes version, and then in the next line we have the the command which will retrieve the add-ons details, that is describe add-on versions, and point giving the input, that is a cluster version, and then output is stored in the result.json file, which is this JSON file. Now if I go to this particular JSON file and try to search a word called VPC CNI, so it will take you to the here. In this one you have the first, you have the list of add-on versions. In that one you can take the topmost, that is latest one. So this is the version 1.18.16-EKS build.1 is our VPC CNI add-on version for cluster 1.3.1. So likewise, if you go for the proxy, right, so that is kubectl version. So this is a kubectl add-on version is something like this, that is version 1.3.1.1-EKS build.2. So those are all the values, we have kept it here. Okay, and that's the reason this help file.powershell script which I have created to help you in this direction. Now how to get the AMID, which I would like to explain now. Now for that case, I will take you to my AWS account first. So this is my AWS account where I'm creating this EKS cluster and showing you the EKS upgrade process. So in this one we go to the EC2 page. So this is the EC2 service page, and then we go to the here we go to the AMIs. In the AMIs you need to so basically, yeah, I need to sign in. So what I do is I'm going to go on a pause and come back after sign in. Okay, so I'm back after logging into this particular portal which was logged out. Now we go to the AMIs. So here in the AMIs, in this drop down option, you need to choose the public images, and then you go to the AMIs, AMI name, and then you go for the AMI name parameter, that is contains AMI name contains, and then what you do is you're gonna put this one, that is contains EKS something. So we try to find out that is EKS. So this is we're gonna use the EKS. So here I'm trying to help you with the the with the filtering. So how do you need to do the filtering? So to do the filtering, what you do is, let's do a reverse engineering. So basically we go here and try to identify this the AMI name, and then from there you can use the the AMI name. So the AMI name contains certain the string characters which I was looking for. So we go for this particular ID and then click enter. So here you see that it contains the name equal to something like this. Okay, so basically if I open this one, so here what you need to do is you need to use these characters, that is AMI name contains something like this. Okay, so this is a one trick that you can filter out the AMI names. So first one we did selecting the public images, and then you go to the AMI name, then you do the contains name contains something like this, that is one. Okay, and then hit enter. So basically it will give you the the list of EKS AMIs of version 1.3.1. Now from here you can also sort it by the date of creation. So we're going to use the latest date, that is this one. So this is how we're going to copy the AMI ID like this and try to put it here. Okay, so once I put it here, basically so this is how this is how we're going to change the AMI ID here. Okay, and then I will go back to the so to this particular version. So here we copied that, right? So I have already copied that in a notepad plus plus, so let me copy from there instead of again doing the redoing the job. So this is what the my parameter looks like for version 1.3.1. So let me copy that, and now I replace the entire thing in one shot. So this is what we discussed, right? So basically earlier the earlier my EKS cluster version was at version 1.3.0. Now it is version 1.3.1. We found out the relevant AMI ID, and this is how you're gonna copy the AMI ID. We got the VPC CNI version by using that command, and then we got the proxy, and the rest all configuration, that is instance count is same, and then the instance size and the name of the cluster should remain same. So I'm going to save this one. So with this we are done with this one, and finally I'm going to walk you through the the specification file, or basically manifest file, which will deploy an application. So here I'm creating or basically doing a nginx the pod deployment. So this is my configurations of my that and it has a service, that is nginx service. Okay, so remember that my service name is nginx service and it is listening on port number 80. All right, and these are all my configurations. Okay, so with that set my with that configuration set in this source code, what did I do is to initiate the process of EKS cluster upgrade, I did simply run the Terraform command. That's all. I didn't go to the the UI. I didn't do anything. But we managing the cluster with using Terraform. So I directly jump for command, that is Terraform init, Terraform up plan, and final command, that is Terraform apply. If you see here, I started to run Terraform apply command. Now, if I come down, basically, it will show you the the things that is going to be modified here, and that is what in the plan also it will be mentioned. So you can expect more changes, because since I was doing the EKS cluster upgrade, with a certain the certain prerequisite, so that's the reason it is showing me one change. But when I did it for the first time, it will actually tell you that it gonna do a three changes. One is basically EKS cluster version upgrade. It will have the add-ons upgrade, and then it will have the node group upgrade. Okay, so basically you will have a three. And since this is in this context, we are seeing the EKS node group update. Okay, remember that AWS EKS node group update, it will take a huge amount of time. When this command is running and you find that that is module AWS EKS node group is still in modifying, in the sense, if when you see this kind of logs, you need to do one more thing. So what is that is we're going to take the another terminal. So this is the my CMD terminal, and here I am taking my EKS cluster access, or basically I'm taking a EKS cluster session in the another parallel terminal. Okay, note that, so there are two terminal running. One terminal we are running the the Terraform apply, where it is upgrading the my EKS cluster, right? So while it comes to this particular stage, that is, while it starts modifying the AWS EKS node group. Now, from that point of time, we take a session. This is the session. In this session, what I did is I did my set up my AWS, the context with using AWS CLI. So I set my access key and secret, region, and default output format. And then we did run this command, that is AWS EKS update kubectl so that my local kubectl file gets updated. And then I did the next command, that is basically kubectl port forward SVC Nginx service 8080. So when I run this command, my application was still running. Why did I try to do that? Because in the one side, we are upgrading the AWS EKS cluster. In the other side, we were able to access the service hosted on the cluster by doing a port forwarding. But in your case, if you have the Nginx, if you have the ingress and you have the ALB, you can try to access your services over the ALB. All right. So now for now, before I show you that, so let me try to show you that this is still working. So if I do a kubectl port forwarding right away, and copy this particular URL, that is 127.0.0.1, and go to the here in the browser, right? And here you go, my application is running. So this was the same state at this point of time. So where were we? So we were here. So basically this is what I confirmed, that it was working fine. Okay, now what did I do is next command is just to check what is the that is the thing that is happening in the EKS nodes. Why did I check that? Because it is running the AWS EKS nodes modifying activity, right? In that case, when I run that command, I surprisingly see that it has the 6 nodes in that one. The old AMI nodes are basically nodes running with the EKS version 1.3.0 images are went in the scheduling disabled state, are basically they are cordoned, while the other new nodes which are created just now, you see that they are created just 15 milliseconds back, like that. So those nodes are in ready state, which is basically a good sign. Okay, and then here you go. So here what we did is, if I show you here, so here then I did run a command called kubectl get pods. So but that was not enough. So then we run the next command, that is kubectl get pods, that is -wide, which means that we are getting the details of the nodes on which the pod is also running. And here if I show you here this one, the selection, in this one we find out that one I know the pod is running on 234 node, in the sense node ending with 234, the internal FTDN. So 234 is basically running on version 1.3.1. So what is the expectation here is, once the EKS cluster is updated, and then the add-ons is also updated, the third component to update is basically node group. So when the node groups is getting upgraded, which means that it has to have the launch template has to be updated, and within that launch template, the managed node, so basically the node groups, the nodes within the node groups has to be updated with the latest launch template, right? And then the nodes as well, right? And that is where this activity is going towards. So we found out that at least one pod is running on a new the new AMI node. Okay, and then then this is where this is the manual way of removing the old resources of the cluster and making everything run on the new. So that is where we are, this is basically an hybrid way of upgrading the EKS cluster. One way you are managing the, basically you are changing the state of your the EKS cluster managed by Terraform. The other side, you are trying to remove the old resources, and that is where I took a kubectl commands help, that is commands like kubectl drain, kubectl basically delete node, like that. Okay, so first one, we discovered that we don't need 3 nodes. You see that the 3 node, when I say 3 nodes, in the sense basically node ending with 87, node ending with 120, node ending with the 150. So first one, we did drain the we did drain the node. Why did I drain the the node 120? If I show you here, So on 120 we have the two pods are running. So first it is important to drain the node. What is the drain activity does is basically it will remove all the the nodes, the nodes that are it will basically remove all the pods that are running on this particular nodes. So pod in the sense our application pods or application containers, right? And the command is kubectl drain. This is the pod name, this is basically our node name. Node name you can find it from here. So if I go to the command output, that is kubectl get pod, so these are the names. So that is something I put in here. And then the additional parameters, that is ignore the daemon set. Yes, daemon set is no need to drain because it will let it kill it as required. And delete the empty directory data, that is something I did it. Okay, so then automatically you see that there are two pods got evacuated automatically. When two pods got evacuated automatically, and then suddenly I run the next command, that is kubectl get pods hyphen o wide, in the sense get again the information of pods, where are they running. Then I suddenly found that the good sign, that is all my pods were try to running on the, so they were started to running on the new version of EKS nodes, and that is 234 to 256. Okay, if I show you that, so here you go, right? So 234, 71, and the final one, that is 252, right? So all the three nodes are belongs to the EKS version 1.3.1. So that is basically, that is what it happened. Why did it happened? Because according to this status, I did the right drain, in the sense I chosen the right node to be drained. Okay, so then my all pods were now running on all the latest latest node basically, yeah, latest the EKS AMI nodes. And then again I run the command called, that is kubectl get nodes. So again we see that the result is as expected, that is same. Now that's where the next command I have started, that is basically delete the node. Okay, so if you see here, the next command what I did is I want to delete this from the node group or from the cluster. All right, so that is where I started a command called kubectl delete node and pass the node names. So I pass the node name 87, 120, and 150, right? And then you see the response I'm getting, that is node this is deleted, node 120 120.us west 2 dot computer dot internet dot internal got deleted. Likewise the it deleted 150 as well. Now then I run the command, that is kubectl get nodes. You see that I got the required nodes. Okay, so I was under impression that this is done, this is actually done. But remember that as I said, let me continue from what where I left it. Basically on the other side we have the EKS cluster upgrade process is running. Now you see that it is continuously running for 25 minutes up to 44 minutes. Okay, so basically I was surprised that it has took up to 44 minutes. So we were here, that is at 44 minutes it got successfully upgraded. When it reached to this particular upgrade, there were certain things also happened in the another terminal. What is that? When I run this command called kubectl get pods wide, I was still in the same state, that is it was as expected, the state, which means that all pods were running on a latest EKS AMI nodes. Okay, and then I did also check the if my service is working fine. Then it is confirmed that my service was working, still working as expected. Then I did a certain couple of things checked. Okay, if I when I run the next command, that is basically, so here we had only three nodes. Now since so here what I did is here after this kubectl get pods output, I deliberately manually went to this particular the EC2 page. So here I went here in the EC2 page, I went to the instance, the instance running. I found there were six, so I manually deleted two nodes. Okay, that is where I made a mistake, right? But you don't need to do it. In that case, just recommendations from my side while you're doing this activity. And eventually that has resulted in a backfire. How? Because cluster identified that so there has some the some error happened, and that deleted the managed nodes of the cluster. Then the the backend process of the cluster has kicked in, and it has started to the recreate the nodes again. You see that it has started to recreate the nodes again. Okay, uh, so you see that the latest node that is created is basically this is the ending with hyphen 30. right, which is 15 seconds, age, okay, which means this is the latest one, right? And while it is decided to remove the another one that is basically 252, right? So likewise, it went on. If you see that, I was keep trying, checking the status of the nodes, keep checking the pods status, okay. So it went into the lot of creation deletion process, right? And finally, it has stabilized in the sense, it has, in this state it used to show me that there are 5 EKS new AMI nodes are running, while my parts are still running on only on the 3 nodes, okay. So those nodes are something here that is ending with 234 71 71 like that, okay. And then as I keep checking, so you see that still here no pods were running on 234, it was running on 71, it was running on 71 again. So I keep checking the status that is same, still here. And the here it has, it has the same status again, that is, we have a 5 nodes. Among the 5 nodes you have the 3 nodes where the way, you have only 2 nodes where the pods are running, where other 2 nodes are not required. So that is the status still here. I keep checking here. And then so here you go, right? So here we had a 5, now it is draining of the another node. If I show you here, so if you see it deeply, so here this one that is ready and scheduling disabled, so this node is eventually removed off, right? And then it tried to take on to the another node that is basically 271 node. So 270 node at this state was in ready state, but now when I run the command again at the one particular point of time, so then it has targeted the 271 nodes to be removed from the cluster, okay. This is basically lifecycle management activity of the EKS cluster. No manual intervention. It is basically managed by or self-managed by the EKS cluster. Now, likewise, if you see that, we are still seeing that here, that is 271 in the ready and disabled state. So likewise, if I go down a couple of steps down, here you go, right? So here we still see that, so we still see that it is 270 is in still in ready and scheduled disabled state. Now again, what I did is I just wanted to check the the part. So this is what it happened. Then again I checked the the status of my application by doing a kubectl port forward to my service on port number 8080 colon 80. The application was still running, right? And likewise, so you see that how much time it has took to come out of this particular state and keep it the only required state, that is only 3 nodes, okay. So as I defined in my EKS cluster definition, so my desired state of nodes is equal to 3. So it is supposed to maintain only 3 nodes in the latest version. And this is what the end result, expected result, where all the EKS nodes which were there in the older version now got migrated to the version 1.3.1, which is basically a final step of the the cluster upgradation. And finally, this is where if I run this command, this is the current status. Now if I go to the my EKS the EKS nodes page, or basically EC2 page, where I can see the EKS nodes. So these are all the nodes. If I can open this one, you see that the AMIs from which these nodes are created is basically the EKS node 1.3.1, okay. So likewise, you see that all the nodes got upgraded. Now let me take you to the my EKS cluster where I did this experiment. So if I go to the my Amazon EKS service page in the region that is Oregon, remember that my region is Oregon, so in your case it could be different. So here I see that my cluster with the name pod cluster is in active state and the cluster version is upgraded. Now let's look at the other components if those are being upgraded. Now let me go to the add-on first. So in the add-on you see that the add-ons or Amazon VPC CNI and the Q proxies are being upgraded to the latest version, right? So how did I say this? You can check the versions, and those are all the versions being mentioned in this Terraform file, okay. So you see that VPC CNI version, and this is a proxy version, so that is getting replicated here, which means that add-ons are being upgraded. Now let's go to the another component, that is compute upturn, compute component. In the compute component we are using worker node groups. In the node groups, you can check the the Kubernetes version, that is 1.3.1, and then status equal to active, like that. Then let me go to the the history, update history. So in the update history, if I show you, so I did lot of exercise and finally come to this, the successful update ID. So this is the successful update ID and it is pointing to the launch template version 2. Now let's figure it out what is the launch template version 2. So if I click on this one, so the launch template version 2, let me take you to from here. So if I go to the launch template from here, from the instances or EC2 page, here we see that the this is the launch template. Okay, so if I go to this one, right, so here you see that if I choose the current version, that is version 2, so this is pointing to the latest AMI which I have defined in this particular Terraform file, that is ending with DDDB. Okay, so that is 3DB, so this is 3DB. All right, so we see that the launch template version is also upgraded. And if we go to the update history, so this is what it looks like. All right, so finally we have achieved the successful state of upgrading the AWS EKS cluster version from 1.3.0 to version 1.3.1. Now let me I know after this command is successfully shown green, I deliberately run one more time, that is Terraform apply. Now it says that there is a zero change to add and zero change to manage. Okay, now let me do this task again in front of you so that you get confident on this. So let me do Terraform apply again. um, so while command is running, so what I do is I will share this source code in my GitHub repository, and the GitHub repository's link will be shared in this video's description. You can use it from there and try to follow the same task. Okay, now I'm running the Terraform apply, and I see that it says no changes. Okay, no changes when no changes at Kubernetes version equal to 1.3.0. Okay, so earlier my version was 1.3.0, but when I changed it to version 1.3.0, 3.1, it is still and the same state. Okay, so this is all about the end-to-end upgrade of cluster version from 1.3.0 to version 1.3.1 while taking care of your application availability. Now let me give you a hint. Okay, so I experienced a weird the error when I was updating the EKS cluster. What is that? When I did the Terraform based, or basically purely Terraform based EKS cluster upgrade, I was encountering the VPC CNI version upgrade failure, in the sense it used to initiate the VPC CNI update, but VPC CNI update was never going into complete. So in that case, I wanted to solve that problem, so I did take a parallel session, something like this. Yeah, and then I use the AWS CLI commands and try to solve that problem. What is that I did is I want to know what is happening in the under the hood. That is, then I run a command called AWS EKS describe add-on. This is the cluster name and the name of add-on and the region. Then I figured it out. So basically the EKS cluster add-on is basically in an update state, or basically it's hung in update state, right? And that is where the problem was. I was not sure why it was hung, but to solve that problem, we have a solution. That is, either you can try to re-update the command, or you can reinitiate the update command, which I did try, but it failed. Then what I did is I deliberately deleted that add-on. In the sense, I just run a command called AWS EKS delete add-on, cluster name, add-on name, and the region. So I clean up the hung update process of VPC CNI, and then automatically then you can use this command. Or the other side, when the where the Terraform is trying to push the VPC CNI will automatically create, or you can rerun this command, that is AWS create add-on with this name. It will create an add-on with the latest version. Okay, and then so this is what the basically tip for you if you have encountered issues in the the CNI upgrade issues. Okay, while we have seen this command, that is basically parallel manual process that you can follow to safely drain the the pods, and then the delete the nodes from the cluster, that is delete the old nodes. Okay, so with that note, I have shown you the things need to be shown in this video. Finally, kind request, please do subscribe my channel. That would really encourage me a lot. With that note, thank you, thanks a lot, and see you in the next video.